Hi everyone, good to see you all again, virtually. And thanks for joining today for Better, Faster, Stronger Streaming, your first dive into Flink SQL. My name is Caito Scherr. I'm a developer advocate, and I work at Ververica, which is a Berlin-based tech company that built and maintains the open source project Apache Flink. To further support Flink, Ververica also built a related integrated platform called the Ververica platform, so that provides analytics and streamlines deployments and other operations and things like that. So that's kind of what I do. And I'm over here in the Pacific time zone in Portland, Oregon. And I first got started with stream processing back in 2017 when I was a software engineer at a large data analytics company. My team at the time built that company's first stream processing data pipeline using Flink. There was very little stream processing in general there, so it was a pretty steep learning curve, but of course also very worth it. Otherwise, I wouldn't be here talking about it. And it does mean, though, that I have a particular soft spot for hearing about people's early adoption stories, and having been through all of those pain points, it's a really big focus of mine to try to just make that a little bit easier for people, especially if you're just starting out, and hopefully a little more fun, because why not? And I got to know my current coworkers when I became a regular speaker at their conferences, and then I got totally hooked once I met the open source community around it, so big shout out to all of those awesome open source community members out there. And really the only downside for working for the Flink people now is I guess I have to like squirrels now, as that's our mascot. So, in all fairness, it is pretty cute, but I do mention this for some real reasons too, which is that a little bit of history about the company I work for. So originally it was chosen apparently because squirrels can land often in like superhero type positions, but also because the rough translation of the word Flink in German means nimble. So we wanted something that could really highlight the flexibility and speed of the framework that they're building there, which will come into play later. So for today's talk, I'll go over the main challenges for the types of use cases that I'll be showing you. Next, I'll introduce the tools that I'll be using. Since this is a very beginner-friendly talk, I want to make sure that all of this really makes sense. So even if you're totally new to stream processing, I want to make sure that's really inclusive, but I'll also be describing everything in the context of these challenges and these use cases. So even if you are an expert, hopefully it won't be too boring, because I'll try to have all of that within that context. So once you have all that, I put together a little demo to show how this can be, how the tools that I'll be talking about can be used to get just the simplest, easiest route to creating a really powerful, scalable stream processing data pipeline. And one note on that is that the demo should be straightforward enough that you can follow along with it while I go, although downloading the tools might take a little while depending on your internet connection, how well your machine's going to handle doing that while you're also streaming this live conference and things like that. But because of that, I'll provide a QR code at the end that will take you directly to instructions and a bunch more information and resources. So I promise I won't leave you hanging if you aren't able to follow along exactly as I go. So yeah, I want to make sure you can do that at your leisure as well. And the goal today is really to show you just how incredibly simple it is to get started and ways to make that even more simple. And then I'll also provide you some resources at the end so that you can keep going and do things a little more interesting, a little more complicated as you get past that as well. So the challenge. So the first part of the challenge is actually a good thing. At least I think it is, but of course I'm not biased at all. And that is, of course, that stream processing is becoming ever more popular. And it's becoming popular for, again, what I consider to be pretty good reasons as well. So with a continuous stream of data, there's a lot of benefits. Most data is already naturally produced in a stream. So whether it's input from a video game, weather sensor readings, customer usage patterns, so therefore collecting and processing data as such is just a lot more natural and allows for a higher level of data accuracy and real-time analysis. So you're really actually, being in real time as possible. So, without breaks and having to wait for new batches like you would with, batch processing, you can also have, really get towards that much lower latency and, meaning that you're going to have a potential for just a much faster data transfer and data processing, as well as reading in that data too. And all of that means that more and more people are adopting stream processing. Even since 2017, when I first got into this, nowadays it feels kind of weird to think about how new stream processing was at this large, well-established company. And but back even just a couple years ago, that was actually pretty common for a lot of companies that I worked with and interacted with. And now, I'm just seeing it everywhere. So this means, if you aren't already using it, there's a pretty high chance that you might come across it in the future. And because stream processing tends to involve a lot of integration points across different teams especially when larger companies implement it, there's an even higher chance that you will have to interact with it in some way, even if it's not your team that's directly working on it. So conversely, this also means that, let's say you're on a team of really highly experienced stream processing engineers. Because the likelihood is so high that your streaming application or service will interact or impact other teams and services along that stream, in a lot different ways than a typical batch program would, your ops team or other teams that deal with internal tools or internal storage, containerization, any team involved in that, especially if that's, split up and you've got team autonomy going on there, those teams will likely also need to have at least some insight into your streaming app as well, which makes the whole situation a lot more interesting. And companies typically switch to stream processing in order to solve a particularly complex problem. Usually because they have massive amounts of data, they need really granular analytics. They need really as close to real-time processing as possible. So if you're using stream processing, you're probably already in a pretty complicated situation, very likely. So on top of that, the more data you have, and the more you want to do with it, the more likely it is that you'll have to use one of the more powerful and more customizable streaming engine, which also means that you're working with something that's also inherently complicated. Okay. So we've learned that, the TLDR here is that stream processing is complicated. All right, super helpful talk, right? Okay, so now let's say you're a stream processing expert and you don't really care about making the initial adoption of it easier. Like your team is already well established, you know what you're doing, no problem, cool. So you'll still need to have, solid observability options that are accessible to these other impacted teams. And that, and that makes sense to those teams who may not also already be familiar with stream processing. So there's just a lot more, complication there as well. And, I've seen where, observability was set up only with the data streaming engineering team in mind only. And, it might seem fine for weeks or even months, but I've firsthand, and from others I've worked with across the streaming community for years, I've just seen a lot of issues coming out at, not always the most opportune moments, and, that might have been boiling under the surface for a bit. So, most of these issues that I've seen usually stem from downstream or other impacted teams who were not included in the initial process there. So I won't actually go into that as much today, but I always like to kind of sprinkle that in here a little bit and kind of set up a little bit more about why it's really nice to have a super simplified version that can be shared across teams that may not have the same expertise as you. Okay, so now let's say you're not a stream processing expert and you just really need to build a new data pipeline really quickly and you want to, for whatever reason, skip all the usual overhead. That sounds kind of great, right? But you still want to leverage all the benefits of those really powerful, really complex, flexible streaming engines. So in that case, it would be pretty cool to have a tool that can streamline that for you. And this is why I've been really enjoying playing with Flink SQL, and that's going to be our demo today. So having done all of this the hard way, multiple different hard ways, multiple times, I just from pure experience, it's been really nice to have a solution to some of those particular challenges. And I don't know if you can tell, but I honestly have way too much fun being able to geek out about it with all of you. So always pretty excited to get to chat about this in talks. All right, so that brings us to our little overview here. So of course, I'm using Flink as my open source streaming tool. And again, since this is a beginner-friendly talk, I want to make sure we're all on the same page. So super quick intro. So what is Flink? On the highest level, Flink is a stateful, fully distributed processing engine for both batch and stream processing, or more precisely, for both bounded and unbounded data streams. And if that doesn't make sense, I'll have some examples in a moment that should make that a little bit more clear. So just going over some of the benefits, the strength is in its scalability, its high performance. So for instance, computations done at in-memory speed, so super fast, got that squirrel speed in there, and various features like exactly once guarantees and very robust high availability options, all of which allow for very granular levels of data accuracy and reliability. Additionally, there's a ever-growing ecosystem around Flink of libraries, connectors, other features, and partnerships with complementary tools and software that have really enabled it to fit into a wide variety of different use cases and pre-existing systems. And I always like to give another shout out here to all of the open source communities that, outside of Flink too, that really make that happen. There's just some really awesome stuff going on. We have a super active mailing list for a reason. It's really fun to get to see what everyone's working on there. So shout out to that if you are really into open source and seeing what cool things people are doing. Last couple things, it can be run on most common cluster environments. So Hadoop, Yarn, Mesos, Kubernetes. It can also be set up on a standalone cluster. All of this means that in addition to, it has a lot of state and timing functionality that allows for a lot of flexibility for what different applications that the runtime can be run on. So as part of that, this is the typical Flink ecosystem. We've got a series of APIs, and the higher level the API, the more concise, but the less expressive, and vice versa. So on the most expressive is the lowest level process functions, and that supports Flink's precision timing, event, and state-related functionality. The mid-level is the data stream API, and that powers the unified batch and streaming functions. So for instance, anything related to windowing, exactly once, etc. And this is where all of your maps, reduces, and aggregations will take place. Then the table API and the SQL client make up the highest level. So our relational API is there. And, that's spoiler, what I'll be getting into in a moment. And both of these are optimized for unified batch and stream processing. So the queries are the same regardless of which processing type you'll be using. And they're also both based on Apache Calcite and therefore are ANSI or standard SQL compliant. Taking a quick step back though, so why even is it important to provide that unified solution? Some of this is pretty straightforward. So, unifying batch and stream processing allows the users to reuse code and reuse logic across, both batch and stream processing. That's great. That's going to make it easier to integrate different applications, different systems. And it also helps ensure that semantics are consistent. So you don't have to learn a completely new API for each processing mode or each layer of abstraction. I won't get into how often I've seen this as an issue out in the world. So, it also means you can simplify your operations by keeping configurations and processes the same across all those systems. One thing, when I say processes there, I do mean technically for the most part and kind of wrapped up in configurations, but I also mean on the non-technical side too, or kind of adjacent. So your process for how you create your schemas and everything like that, or just your development process in general for your teams. I've noticed that this can actually, the side effect is that it can really help simplify that as well, which is nice. So, and then of course the coolest part is it enables you to mix your historical and your real-time data and to be able to do that pretty seamlessly. So as for the architecture and kind of how that works, this will look different depending on what your use case is, of course. And, whether or not you've got batch or streaming. So that's why I've got the examples of both here. But I want to show a pretty common example for both. So I was going to say on the left here, but I realized my video might be mirrored. So not going to say left or right. I'm just going to say the one that says batch on it. So yeah, hopefully the labels, I hope you could read those. So in the batch example, we have our recorded or historical events. And although these are queried periodically, Flink has very precision timing capabilities, so it actually could be done pretty efficiently, which is nice. And on the other side, I'm not going to say right or left again, We have our more common streaming scenario, and that relies more heavily on Flink's internal state functionality. The most typical use cases for this are going to be event-driven applications, data analytics applications, and data pipeline applications. My experience is mostly in data pipeline applications, so that you'll hear me talk about that a lot, even though it applies to all of these and more. And side note here is for its state, Flink uses this unique checkpointing and safe pointing system, and unfortunately, I probably won't have time to get into it today. It's actually the thing that helps support my favorite feature. So that main benefit of it is that it enables the truly exactly once guarantees on data, and to have that be scalable with very minimal performance overhead. So if you're like me and you really like geeking out about that, I definitely recommend looking it up. It's pretty cool how that works. So even if you're going to be using the more abstracted SQL version, I think it's nice to kind of know what's going on under the hood. I think also for a lot of people, like for me, it kind of helps make the architectural diagrams make a little more sense to see what that typically looks like in the code. So here's just a very simplified version of just a really basic Flink data pipeline. So again, this is not using the SQL client, just regularly. So, and again, especially if you're new to stream processing, just to kind of show you and walk through like what that typically looks like. So you start by reading from your source. In this case, we're reading from a Kafka topic, which is one of the most common, along with like a Pulsar topic. Next, again, super simplified representation of our business logic for the Flink application itself. So, doing a couple basic transforms here, maps and reduces being the most common to start with, of course. And moving on to things like specifying what you want to key by and, configuring your window settings and things like that. And, normally there'd be a lot more in between here, but in this very simplified summary, we end with designating and writing out to our sinks. So with Flink, a sink can be a wide variety of things. I'm always excited when I can say that sentence. It's a good tongue twister. So the sink for Flink can typically be, it's usually more like a data store database, but it can also go to another application or be consumed by another message queue, like another Kafka topic. And you can really even just chain it in a lot of ways and get multiple different Flink applications and message queues and things go in there and make some really fun, complicated things there. So as for why I'm going to be focusing on just Flink SQL today and not the rest of what I just talked about. So firstly, there's a lot going on with Flink and with a lot of the more complicated stream processing engines. And for any of these really powerful, flexible, customizable stream processing engines, that's what makes it such a powerful and flexible tool, but it also means that it can be really nice to have an option that allows you to jump right in and start building something that has all those strengths, like one of those very powerful streaming engines without having to do a whole deep dive into the complexity of it. So as a couple additional points here, Flink is also typically written either in Java or Scala. There's also now a PyFlink UDF. So if you're using regular, vanilla Flink, it is a little language dependent. So if you're using Flink SQL, that allows you to have a very language agnostic data stream, which is awesome. So that code example of that typical Flink system, as I mentioned, that was very simplified. You are likely to have a lot more going on there. And of course, as I mentioned, language dependent, and also typically some other dependencies. So, and even on like a basic level, you're going to probably need to use like a pretty powerful IDE. So even at that level, things tend to get a little more, complicated there. So I will get into Flink SQL's actual inherent strengths in a moment, but I just really want to emphasize, that ability to simplify your development and really kind of keeping that as the theme today. And one additional thing there, so Flink SQL's capabilities there, it's actually very stable. So Flink SQL has been a part of the Flink repository. It's been about 6, almost 7 years at this point since they started adding that to the repository. So as I mentioned, it's also based on Calcite. So it does support regular SQL. So if you already know SQL, there's not really going to be a learning curve besides the basic streaming concepts. So this is one of my favorite parts for the simplicity portion, just because it's very visual. So this is an example of sessionizing clickstream and count on a number of clicks per session in regular Flink using the DataStream API versus using Flink SQL. And it doesn't really matter too much what this is actually doing. It's kind of just a fun little project that I like to show. And, with Flink's other APIs, queries are still going to be dependent on a table program written either in Java or Scala. And often, those dependencies are going to be on, you've got build tools for submitting a cluster, things like that. Whereas the Flink SQL client, all writing, all debugging, submitting any sort of table programs to the cluster itself, all of that's just done. Plus, you can get your visualizations in the command line, which personally, I'm a very visual person, so I really enjoy that. Spoilers, get ready for some gigantic squirrels in your terminal. So for the actual benefits of combining SQL with a powerful streaming engine. So this is where it gets really fun. So we've covered that, you get to use SQL. It's easy to learn, or, virtually no learning curve if you already know SQL. While you still also have access to all the benefits of, unified batch and streaming for a distributed system. And with that, of course, users are able to focus on the business logic and less of the implementation details. Of course, you don't have to worry about switching your code over, less of a learning curve. So we already kind of covered a lot of that. All of this making it just a very lightweight option and, being able to just give developers more autonomy to jump right in. And as for some of the real world use cases that we tend to see, we've been seeing a lot of machine learning coming up. So being able to more easily generate features for model training and specifically building unified pipelines for online and offline model training. So that's one of the ones that I've just found to be one of the coolest things to see people using this for. And, another thing that I personally really, really am fascinated by is, building these end-to-end streaming analytics pipelines without necessarily depending on a dedicated engineering or operations team. So kind of decoupling that. So we actually are seeing people from all different parts of engineering and even non-engineering being able to dive right into this and being able to kind of communicate between engineering teams and ops teams and others who, if all they need is basic SQL knowledge and some streaming concepts explained to them, can actually, understand a lot of what's going on here, which is pretty neat. So what the actual benefits look like kind of under the hood here. So this is going to be your regular basic, not Flink SQL, regular SQL engine. So, in your regular database where you execute your query, it's done at a certain point in time. The engine takes a snapshot of the table at the time the query was run and then computes the results based on that static snapshot. Then the query terminates. So, pretty basic regular system there. But in streaming SQL, the query is continuous. So you first deploy your query, and then whenever data is added to the table, the changes are continuously ingested and results are also continuously updated. So the query just keeps running and never finishes until you actually cancel the job. So on the surface, it looks just the same, but you have access to that actual continuous streaming functionality that's going to give you that higher data accuracy and that, closer to real-time processing, which is pretty neat. So in a nutshell, before we move on to the demo, just to recap, so, what Flink SQL gives you is this high-level relational-like way to query your data streams using a language that you're more likely to already be familiar with, or that your other, sibling teams or other people at your company are more familiar with, which is also nice, even just in order to communicate to someone else how you're impacting, that internal tool that you share with someone and things like that. And it's optimized to handle both batch and streaming workloads in that unified way. So you can use that exact same query to process your real-time data and, let's say, a file stored in an S3 bucket, without changing any logic. And besides the operations that you might already be familiar with from regular SQL databases, your joins, aggregations, filters, there's also support for really advanced streaming features as well. And so you also have time traveling, change data capture, things like match recognize, among others. So there's really kind of a lot packed in there as well. And, with something as simple as SQL, being able to use that and build applications with the same performance and scalability and consistency of any other Flink program. So, you've got that. And then, of course, the whole ecosystem around it, all of those awesome open source communities that have really done some amazing partnership work with this. So you kind of get access. I love this image that my coworker actually put together of just this little slice of kind of what you get access to there, which is kind of fun. Okay, so now the fun part. So again, I wanted to make this as simple as possible so that you can follow along, or, at the very least, it's like 3 steps for the prereqs. If you don't have time to screenshot it, I can try to talk slow if you need to screenshot it. But hopefully this, you might even just be able to remember it and write it down later or something. So there's actually going to be a couple short demos in here, but they all use the same prerequisites. So one note here, the Java thing can be confusing to people sometimes, but I promise I am not going to make you write new Java code. Nothing wrong with Java, but I'm not, you don't have to write any today. But you do need to make sure that you have Java 8 or Java 11 installed on your machine. So otherwise, once you make sure you have that, download the current stable snapshot release of Flink. So that's just the basic, on the download Flink page, and then you untar it. So 3 simple steps there. So then all you need to do is start a cluster. And at this point, you'll be able to open up the Flink UI that comes out of the box of Flink. So at this point, you'll be able to just open localhost and it should just show up, boom, instantly there. And you should be able to see everything right away too. So everything's right there, everything that all the basics that you want to measure. And then you just start up the SQL client. And a note here is that you can actually start it up in different ways. So you can explicitly use things like embedded mode, among other options. So again, I'm just picking like the simplest route here to show you. So you are not going to miss that you are in the SQL client. There is definitely no, oh no, did it work? Because you will immediately see this gigantic squirrel. If you do not see a gigantic squirrel, then something is wrong. So you won't miss it. And just while we're looking at this beautiful giant squirrel here, great time to mention a couple side notes here as part of other things you can do to start it up, and just so you kind of know what you're looking at here. So the SQL client supports 3 modes of maintaining and visualizing results. So again, I could have started it up differently depending on what format I wanted to see my data in and, and all that. So you've got table mode that materializes results and in memory and visualizes them in a regular paginated table representation. You have changelog mode that does not materialize results like that, but instead visualizes the result stream that is produced by that continuous query, consisting purely of insertions and retractions. One note about that is that in order to stay responsive, since the results in that case for changelog are still stored on the Java heap, the changelog mode will only show the latest 1,000 changes. So if you want more than that, you'll need to kind of work around that, customize that. So just so you know, so you're not alarmed if you only see the first 1,000. And the last one is Tableau mode, which is more like a traditional way. So that, you're going to display the results on the screen directly in Tableau format. So the displayed content there will be influenced by the query execution type for all these cases. So now that we've gotten to see the squirrel, probably enough, maybe enough. So this next part is very basic, but I always like to check the built-in hello world function because it is really the fastest way to find out if something's wrong. So even if you're in the SQL client, and you've seen the giant squirrel, there's still this one more check that it's kind of my public service announcement for today. So if this doesn't work, if you don't end up seeing the Hello World app, there's a couple ways to troubleshoot that. So typically this either means that your client and cluster might be on different versions. So if you are doing this right now for the very first time, it's almost impossible that that's the case. But if you somehow already have another version of Flink downloaded somewhere on your machine, that, there's a possibility that you just want to make sure that your client and cluster are on the same versions of Flink, and or you might have overridden your default ports somewhere. So those are typically the biggest troubleshooting points for this section. So again, PSA, I know it's really basic, but I definitely recommend doing this just really quick test before you start throwing queries in there. So we've covered the initial steps for pretty much any Flink SQL work that you're going to do. So that is all you need to do to get started. And then from there, again, starting with the most basic, the simplest thing there, and then I'll do kind of like the next simplest thing. So in this one, I'm just going to read from just creating a table, reading from a local CSV file. I picked something that I was actually already using in my personal life. So for context, a bunch of friends contributed to this fake journal or fake diary titles for their experiences during quarantine, during pandemic. And it became this humorous, but still, really hoping to be very inclusive and relatable way to share a lot of feelings that came up this past year. Sometimes in kind of a cynical way, but so people got so into it that within about 3 days of telling friends I was doing this, I had over 100 submissions from friends and family spread across Slack messages and text messages and everywhere. So I wanted to create a data pipeline where people can just throw things into the pipeline. In this case, for this demo, I decided to just have it download as a CSV file regularly, just again to be able to show you what you can do just on your local machine. And, so I wanted to make sure everyone could add to it. And then the idea was that I wanted to quickly sort and determine which ones I had already made into these fake book covers that I was adding to my website, but more importantly, which ones were work safe so that, because a lot of people were wanting to share them at work so that they could be safe to do so, that their job would be safe if they wanted to save these, share these. So now we've submitted that. Again, this is just like regular SQL. So you just select that table and there you go. So if you've been following along, you've made a data pipeline in 3 steps. So I know not including the prerequisites. So this is not surprising for basic SQL, but that's kind of why I wanted to show this, is that it's genuinely as easy as that, except for what's going on under the hood, but the fact that this is running those continuous queries. So this is a pipeline that can genuinely scale up with you because it has access to that incredibly powerful stream processing engine and that access to that unified batch and streaming functionality. So an additional note here, though, for that part of the demo is that the Flink SQL client provides output in real time, but is also read-only. So storing results, if you want to power a report or dashboard, that's going to require writing out to another table. So this is also super easy. So I was debating whether or not to include this as part of the 3 steps because it's not essential. I left it out as an optional 4th step. So it's again super easy. You just do this insert into statement. And then once submitted, this will run and store the results into the sync table directly instead of loading the results into the system memory. So if you want to do that, then that's 4 steps. So 4 steps, and you've created a very scalable streaming data pipeline that can now store results into a sync table. So now, and I know I'm getting a little close to time, so I might have to start speeding this one up a bit. But since we do still have a couple more minutes, this is more of a true streaming situation, what that would look like. So this is going to contain way more data coming in at a super high throughput. So this next demo, the steps start out the same. So you just add this next table. You can add it to the same session if you're following along, as long as you don't mind having that random local CSV file floating around or that random table there. So all the startup steps will be the same, unless you're connecting it with another tool that doesn't come out of the box of Flink. So in this demo, I'm using Datagen, which actually does come out of the box with Flink SQL. But if you wanted to add more tools to your pipeline, Hive, Postgres, Grafana, you would of course need to download those and incorporate those at this point and, set them up in your SQL client or in a script. So I'm not adding examples of those because, those tools all already have great documentation and you can often follow along for regular SQL. Flink also has documentation and often special connectors for a lot of the more common streaming and streaming adjacent tools to make that easier. So again, I won't cover it here. So in this example, as I said, we're going to use Datagen, which is very similar to Faker. So basically a synthetic data set platform that's highly customizable for a wide range of use cases. Datagen is another awesome open source tool that I really like to leverage for projects like this. And if you're not familiar with them, they're actually more known for their 2D and 3D humanoid motion algorithms and computer visualization system training data, but they also have these more, basic options too. So as I mentioned, Flink has a Datagen connector, and that connector allows for creating tables based on in-memory data generation. And that's going to be really useful when developing queries locally without access to external systems like Kafka. And tables can include computed column syntax, which also allows for more flexible record generation too. So no additional dependencies required. And by default, Datagen table will create an unbounded number of rows with a random value for each column. So for variable size types, char, varchar, string, blah, blah, the array can be specified. And then additionally, a total number of rows can also be specified if you want to have a bounded table. So there's actually quite a bit more there that's really fun to look at there, but for time's sake, I will keep going on that. But basically, yeah, then you just show results. And this demo is literally how long this took. This was actually even on a really old computer where I forgot I was running a bunch of Docker and stuff in the background. So it is just super fast to be able to just immediately view everything in your terminal for a really, truly massive data set here coming in pretty fast. So with that, you now have the basics. So if you want to keep exploring, there's a really great demo that one of the founders of Flink created and that my coworkers have been adding to. So it is a data pipeline which all in one does pretty much all the most common functions that our users tend to use Flink SQL for. So it provides data from different storage systems. It uses Hive Metastore for external persistent catalog. It really shows that batch streaming unification queries in action. It has different ways to join dynamic data, and it shows how to create tables with DDL, maintains and serializes views with continuous SQL queries in Kafka and MySQL. So I definitely recommend checking that out if you want examples of all of those cases in one, and how they interact with each other and what you can really get out of it when you leverage all of those combined tools. So definitely recommend that one. But if you want something in between the really basic, straightforward thing that I've shown today, or that larger demo, then I would definitely recommend the Flink SQL Cookbook. So this is a GitHub repository of many different short examples of what you can do with Flink SQL, and starts with very step-by-step basics and gets progressively, more complicated and more things added. And my coworkers have been adding to this consistently for, I think, a little over a year now. So there's a lot of really cool stuff in there. There's also just some really nice demos in there. And with that, thank you all so much for joining today. And if you want access to all the links and resources, feel free to grab the QR code here. And with that, thank you all so much for coming, and a huge thank you to the DataCon LA conference staff and everyone. You've all done an awesome job. Great to see you. And if you want to stay in touch, feel free to reach out here or check out any of my blogs on Medium. I'm going to try to have one about this coming up soon. And with that, take care. Bye.